I'm Kashif, a cloud support engineer here at the AWS office in Sydney. Today I'm going to show you how to rebalance uneven shard distribution by updating sharding strategy. Let's get started. Sometimes disk space in an Amazon OpenSearch service domain is unevenly distributed across the data nodes. This is normally due to uneven shard sizes across the indices. There are several ways to rebalance the shard allocation, including updating your sharding strategy, or adding more data nodes, or by deleting unused indices, or using index state management to automatically delete old indices, or even by moving old indices to low-cost ultra-warm storage. Let's take a look at how to implement updating your sharding strategies. After logging into the AWS Management Console, navigate to the Amazon OpenSearch Service console. Choose your domain and then choose OpenSearch Dashboards URL to open OpenSearch Dashboards. Choose DevTools. Now we can see the console where we'll be running commands. Let's check amount of disk space available on each node by using command as shown. Choose the play button to run the command. We see that for two nodes, disk space is almost full, but each node has equal number of shards. This is because by default, Amazon OpenSearch service evenly distributes the number of shards across nodes. This distribution is not based on individual shard sizes. So if some shards are very large compared to other, then you might see uneven shard distribution and lack of space on few nodes. Let's check shard sizes by using this command. This output shows the size of shards for different indices. We can see that index with big shards has very large shards, while index small shards has very small shards. So although there are equal number of shards on each node, some nodes have very large shards. Let's take a look at data skewness, where shards of bigger indices reside on only a few nodes instead of being distributed across all nodes. Check the sharding strategy for indices by using this command. We see some indices are too big and some are too small. Let's fix it by first splitting the large index and then merging small indices using reindex API. Note that it's a best practice to stop adding new documents to source indices before starting reindexing operation. Even though reindexing can be performed in a live cluster, it's also a best practice to do this during off-peak hours so you can minimize the performance impact. To improve reindexing performance, I'll disable replicas and increase the refresh interval to 120 seconds. You can try other steps to improve indexing performance. For example, temporarily disabling the refresh interval, increasing the value of index translog flush threshold size, using slicing, and so on. Now let's create destination index without replicas and with an increased refresh interval to improve indexing performance by using this command. Next, let's use reindex API to copy index with big shards to destination index with increased primary count by using this command. This can take a lot of time depending on cluster resources and size of source data that's used when performance optimization is done for indexing. Let's use the Tasks API to monitor progress. When re-indexing is complete, we'll enable replicas by using this command. Now, let's set the default value of 1 second for refresh interval. Now, if your application allows, delete the old index to free up disk space. Let's merge small indices to create a large index. First, create desired destination index without replicas, with only one primary shard and with an increased refresh interval by using this command. You can adjust the number of primary shards based on your data size, but you want to make sure that the resulting shard size is at least 10 to 30 GB. Next, use the reindex API to copy small indices to merge index with reduce shard count by using this command. This will again take a lot of time depending on cluster resources and size of source data and the performance optimization done for indexing. Let's use Tasks API to monitor progress. When re-indexing is completed, let's increase replica count from 0 to 1 by using this command. Next, reset refresh interval to the default value of 1 second. If your use case allows, delete old indices by using this command. Finally, let's check amount of disk space available on each node by using this command. This shows more balanced cluster in terms of space compared to start. Thanks for watching and happy cloud computing from all of us here at AWS.